Okay, good morning everyone. Welcome to this morning's Masterclass, really, on Tasmanian timber. So my name's Greg Nolan. I'm an Associate Professor at the University. I'm a registered architect. I'll take the practicing back a little bit. I'm a timber design specialist, and we've been working in association with the Tasmanian wood products industry now for a better part of 25 years. So when I was asked what would be useful for encouraging and supporting designers and producers and installers and industry on exactly what would help with design and getting Tasmanian timber back in the public profile again, then holding a series of masterclasses sounded like a reasonable idea. So it gives me a chance to show off. And it also then let a whole lot of things be aired and people ask questions. So first of all, I want to cover just the technical resources that are available for you. Now this is a Tasmanian timber site. You've got banners here and here behind me. And on that site is a range of brochures which deal with a whole range of species information, a whole range of application information, and show a whole range of projects. And a lot of the projects I'm going to show today and talk about are actually ones that are on the site already, or which I've put in from my own little personal collection. Now, there's a free call number at the top, 1300 number, and I'll show you who that phone call, if you ring that number, who that call goes to during the presentation. And if it's too complicated for him, the question comes to me. So whatever level of support you need, we can effectively supply it outside of doing it for you, if that makes sense. So we can provide that level of advice. And that level of advice is supported by industry. I think in that then is that we act on as a broad technical support for everybody in industry. We don't act for any company per se. So occasionally the things we say won't make one person happy, but they might resolve an issue. So the content today is we want to look at first at species and products. I'm going to take this a little bit to first principles and then back up again. So we're going to look at species and products. We're going to look at applications and designs. So a range of applications of what the material can be used for and is used for regularly. Then looking at a whole series of projects in which it has been used, from little houses to big public buildings. We'll then have morning teas coming out. We'll have a break somewhere in between applications and case studies. Maybe before case studies, maybe before applications, depending upon how long I've gone. So this is a brand new presentation. So I haven't timed it yet. We'll then have a Q&A where a number of members of industry have agreed to come to the front with me, and we'll field whatever questions anyone wants to throw at us. Since it's the middle of winter and dark mofo's on and it's a Friday, I thought I'll do a presentation with as fewer words as possible. So I've probably got 100 words across the whole thing. That might be too many. But I've got lots of pictures because I'm an architect by training, and so I would rather just show you an image of something, describe why it's important and why you've got to take it into consideration, and then have you go to the technical support and learn about it some more, rather than me put up too much technical stuff and boring everyone to death on a Friday morning. Okay, so before we go into the detail though, there is something I always want to address, is why are we interested in wood so much? Why am I interested in wood so much? And it comes down to this basic statement, is that sustainable development requires an increased reliance on renewable resources and an economic withdrawal from non-renewable ones. Okay, now if you take that as a simple statement and then you try and apply it, we can then look at what we've got as renewable resources, what we can have as non-renewable resources, and how we can shift from one to the other. If we look at a definition, is that renewable resources are those that can be returned to their previous stocking levels after exploitation, so we use the right word, it is exploitation, by natural processes of growth or replenishment. So there's things that we can collect that keep on coming back to us, like waves and sun and wind, and there's things that we can grow, like these iris. Okay? Now, if we're looking at organisms, they're a renewable resource that can regenerate and regrow, and to provide us materials such as wood, grain, fuel and fibre, and we exploit the genetic diversity of the organism to give us different things, if we want to put it in the simplest terms. So as I move along, we're going to talk about different species. So different species are obviously, we're exploiting the genetic diversity of the trees for our own purposes. Now that makes it really, really different than working with a bit of plastic, because the plastic has been made from an industrial process where people, engineers, have designed the plastic to do a job. The organism hasn't. The organism has designed a job for the animal or for the grain, the tree. And so we've got to use the genetic evolution of the tree or the animal to give us the things we want. So the genetics determine what we can get rather than an industrial process. So what that means then is that most of the stuff we deal with whenever we're dealing with renewable materials is tricky, because you're always having to cope with the variability that the genetics gives you. And as we move along, you know, all the things I can tell you about ways we handle with wood, ways that this is different to that piece, and why this piece is unique, you know, every piece is unique and why, we've got to compare that to something like steel or aluminium or glass, where we buy glass from here, we buy it from China, we buy it from Sweden, it's glass, you know. We can specify exactly what we want. If we go wood, and we go wood from here, wood from China, wood from Sweden, every one of those species is going to be different. And there's all these tricks we need to play with, understand if we're going to use their species or they're going to use ours. So wood gives you a difficulty because you've actually got to appreciate all these things are different. But it also gives you something you can show off with, because you can describe the characteristics of the place, the terroir of the piece, which you can't do with another material. You can't do with something you make. Okay, so as we move through the day, just keep remembering that each one of these pieces is unique, and we've tried to pull them together into groups so that we can get a suitable usage out of it. And if we're being responsible, we want a usage from as much of it as we can. Yeah? So just saying, I only want the clear bits within this colour range automatically excludes a whole range of other stuff, because the tree is not something you can dial up like a steel plant. Yeah? So, all right. Is that theoretical enough? Good. Let's start from there and let's look at Tasmania's resource. So I've just got some pictures of the forest resources that we utilise. So this is a bit of native forest bush. I think this bit's up near Smithton somewhere. It's grown from, it's a native forest, which means is that the trees have evolved to grow in that place. And when that spot's harvested, the seed from those trees is used to regrow the trees on that spot. And that's the basis of most native forestry in Tasmania. So you collect the seed from the area, that seed is then put back onto that spot after harvest, and the trees regrow. Now, a couple of things that does. The trees grow slowly. So one of these things here, you know, that one might be 80 years. You might have 90 to 100 years between harvest cycles. Well, that might be what's planned. It might have been harvested in 1840, been burnt out in 1910, and this is what it looks like today. Okay, so forests keep on wanting to grow back. If we want to get rid of the forest, it's a really positive process that we've got to continue to do. So this is one resource, and a lot of species we'll talk about today come from this one. Of course, these are the higher end interior design, interior application type species. This is another resource which is this one but underwater. So if we talk about hydrowood, you can see the banner here, and I can hold up a bit with a label on it, then it's the same species as grew on land, but it's been flooded. So it was flooded under dams, and so there's a company, Hydrowood, who are collecting it out of the water, and then they're milling it. Now we've got two other major resources in the state, and both of these are plantations. So a plantation is different to a native forest, different quite a lot. Because with a plantation, you select a type of tree that you want, and then you select the best ones of those types of trees, and you plant them in seed. So it's, I'm only going to grow the ones that grow fast and will grow straight. So you select the seed, and then you plant it, the seed or a seedling, at regular intervals. And then you might thin them out a bit so it looks more natural, but actually all the trees are the same age, they're all the same species, and they've all been selected to grow quick. So they might look natural, but they're not. So that's this stuff. This is, it's either blue gum or it's Eucalyptus nitens. So in Tasmania, we're now harvesting almost 3 million cubic metres of Eucalyptus nitens in the state at the moment. It's close to 3, it might be 2.8, most of which is being currently exported as fibre source, because that's what it was grown for. There is some resource that's currently being grown like this, which is, you see these stems have got no branches on the bottom. The branches have all been cut off when they were small, so that you're getting what's called a pruned stem. So the tree gets clear wood across it, which means that you end up with something that looks more like that than something with a big branch line through it. Okay? The bulk of it isn't like this. The bulk of it's got lots of little branches on it. Okay, so we, Seesaw, at the university, we're currently doing a whole range of work with industry, and hope to do more in the next couple of months, onto how we can make this into a whole range of building products. But it's not a topic for today because none of the producers have got it yet. One producer's got some in their kilns, but it's not something we can give you and say, okay, here's all the properties like we can with these ones. So that's something to be coming up. And these are pine logs. So in the state, we harvest something like 450,000 cubic metres of pine a year, or pine sawlog a year, and all that goes into effectively one mill up at Bell Bay, and it's converted into framing. Since we're dealing with interior design today, we're not necessarily looking at structural applications. But that's there, that's being milled, it's being used, converted. So what I'd like to do now is just touch on species. So I've got here a little quote. I don't think he thought I was going to quote him. But just as an outline, we've got a pretty good colour range that we can get out of the species that we've got available in the state. Now I'll use these ones. I mean, these are all hydrowood. I'm not preferring hydrowood over the other ones. It's just they're easier to handle. Okay, so we've got a range of different blondes and light browns. we've got a range of browns of different intensity. That one's blackwood. We've then got some reds in myrtle, and we've got some really, really pale, fine-grained stuff in celery-top. Later on, we'll describe the volumes we've got of this stuff, because the relative volumes change a lot. Now, which is another realisation with wood, or especially with the things we're dealing with today, compared to steel production, brick production. No matter how much everyone here says, oh gee, okay, we now want to use lots of these species and want to use them all the time. The thing is unless we've grown them, unless we can harvest them, you can't use them. That's it. There's only so much. If we wanted to grow more of any of them, then that's fine, but plant them today and wait 50 years. There you go. So if we look at the plantation that's now coming on stream, it's all had a 25-year growing cycle. So it was all planted in the 1990s to the 2000s. So what we're harvesting now at 18 and 20 went in, I don't know who was in government in 1990, but whatever. So that's when the trees went in, and they're the fastest ones we've got of growing. So we need to frame our use around supply. So we look at our species. I'm going to show you better photographs of Tas oak and other species as we move along, but I'll just frame some things back to production at times. Okay, so this is Tas oak. Anyone who drives around the state and drives past sawmills in the Ewan, this is at Brighton or up north, will have seen racks of wood like this. Okay, so this is a process called air drying. It's a process whereby the board is cut, the board has a high moisture content, you rack it, which means as you space it apart, you give it even airflow, and you want to dry the timber down at a slow rate. If anyone wants to have a detailed discussion of this, I could do 40 minutes on that. But interestingly, one important thing I'll bring up, which I'll explain again in a bit more detail later, is that if we measured that rack, when we put it out, we'd have a particular height. If we come back 3 months later, it's going to be 50 millimetres shorter, because the wood's going to shrink as it dries. And that's really important for us later on when we design something, because it doesn't just do it here, it does it too when we put it in the building at a particular period. So the timber's racked, this is all Tas oak, so when you drive around, this is the sort of thing you normally see. Later on, it then becomes these sorts of products that you can see here. Now, Tas oak is a trade name. It's a trade name for 3 species, Eucalyptus regnans, Eucalyptus delicatensis, and Eucalyptus obliqua. So obliqua in Victoria is called messmate. It's not called that here because our Eucalyptus obliqua and the one in Victoria is a bit different, only because of the growing conditions. But most of Tas oak now is actually obliqua, about 70% of it, because a lot of the regnans and delicatensis is grows in bigger trees and nice wet areas, and it photographs well. So most of it's in reserves. So there is a particular stock of this stuff. There's about 135,000 cubic metres of material harvested every year, which is then converted into board. Our next major species is blackwood. So I'll pass some of these around for those who haven't looked at these in any detail. So blackwood's a wattle. It's an acacia. So there's a range of different wattles we have available. Blackwood's the major one that has been in the supply chain. Most people like the colour the most. There's another one called silver wattle, which is a pinker, more orange timber, which is equally lovely, but there's not as much of it. So blackwood's in ready demand. and blackwood's been highly prized for furniture use. So you can get greater detail about all these species off the website, as I said. So I might just pass some of these around so people can have a look. So that's the oaks. The next major one's myrtle. So this is myrtle. Myrtle in the log grown in some locations, I'm going to be really quite specific today, is red like that. There's other myrtle grown in other locations that isn't red like that. It's actually much paler, and sometimes it's pink. Now, I don't know how much of the pink stuff's available because it doesn't get sawn much because people won't buy it. They say, oh, myrtle, that's myrtle, I can understand that. You give me this pink stuff, it's not myrtle, it can't be, it's different, see, it's pink. So there is this variation between what people will understand as something and what the tree understands as something. You know, because the tree, if we come back, the tree's growing, it's got genetics, it's in a location. If it's in a good paddock, batch, site, it's getting soil nutrients, and that's making it red. If it's in a different spot, it will grow, but it might not make it as red. So as designers, with some of these more infrequent species, actually discussing things with your supplier about what you've got is actually quite a reasonable thing. Again, it's not the same. It's not like glass, you know, I want glass, and it can come from anywhere in the world. So this is what everyone understands as myrtle. I've got some pieces here which I'll pass around in a second. Now, this is a very, very ancient species from Gondwana land. It's Nothofagus species. You get it here, you get it in Chile, not this particular species, but other ones of the same family, and you get it in New Zealand. But that's a very few places where you'll actually get a Nothofagus like this. It's very, very fine-grained material. It's beautiful to work with, lovely colour, but there's not that much of it available. Actually, quite a lot's coming out of the lakes, from the Hidewa wood, because all the dams obviously were in very deep, dark places, and that's where myrtle likes to grow. Myrtle is what they call a climax temperate rainforest species. So myrtles will grow to 800 years, 1,000 years. Oaks won't. They'll only grow, the oldest ones are about 300 years old, 350. Then they fall over. But the myrtles don't. So there's some... who got that? So with myrtle, you get a really lovely lustre in the wood. Next one, celery-top pine. There's not a lot of celery-top in the state, so supply is relatively constrained. I'll show you a little image in a minute. But it can be really beautifully used where you can put it. There's one thing about celery. Is that celery is more durable than most of the other species we've got in the state. It's a bit like Ewan in that it's a very slow growing pine tree, and the only way it can survive growing slowly and not be eaten by fungi is by having something in the wood which makes it more resistant to that process. So it's very white. When you buy it cut, it doesn't stay white. It goes honey-coloured. So most species, all timber is photoreactive. It changes a bit under light, and celery-top is particularly that way. It goes from pale to light mid-brown, honey-coloured brown. but it is durable. Here's it being used at the TMAG, and up here on the left is an image of it being used in a very large, the Sapphire Resort on the East Coast. Sorry. Okay, so if we look at supply and relativity, this is almost a logarithmic diagram rather than an absolute one, is that with celery, top and myrtle, we have relatively limited supply. With blackwood, we have better supply, but still not a lot. There's never been large amounts of blackwood. Blackwood grows, if you're growing blackwood to any size, you need a forest that has had quite a bit of age. And in Tasmanian oak species, there's much, much more of that by comparison with the other species. However, you can use them all and then in a whole range of different combinations. I'm happy, we haven't discussed this, but I'm happy to make this presentation available as a PDF for whoever wants it. And I'll see if we can arrange it for it to be put up on the website. It's being recorded today, both this morning and this afternoon. So if you've got colleagues who you think might find it of interest, then you can refer them on. Okay, so we look at products. The first lot of products we've got are things called sawn and moulded board. So I'm looking at things then that your joiner or you might buy from a shop or a store then to make things from. So all of this is sawn and moulded material, and this is all Tas oak. It will start out being pale pink, and the photograph over there was just in a brown shiny environment, and that's just the way that the colours came out. But that's all moulded. This is all sawn material, graded, ready to then be translated into something else, and the other is then a moulded product where you've put it through, you've dressed it each side, and you've put tongue and grooves in it, in this case for flooring, and that's readily available for you. A next major product that's now being made in the state is plywood. Now, I don't have a good image of the plywood, but I've got a good image of the veneer. So this is one of the plywood presses that's in a mill at Taran's mill at Smithton. So that's a pre-press. So what you do is you lay it up, you press it once to keep it in the right shape, then you put it into a different press which puts heat and pressure, more pressure on them, and that gives you the final bond in the glues. But these are the veneers that are peeled then to make the plywood. Now, there are representatives of Taran here today, so if you're interested in plywood, then by all means have a chat to them. There is a project later on which will show Tas oak plywood that's being used in ceilings and floors. So the next major product type is really veneers. Now, veneers, these are different than plywood manufacture. So if we're making plywood, we're going to take the log and we're going to peel it. So put it on a big spindle, we put a blade on it, and it all comes out as a strip. It's usually 2.5 to 3.5 millimetres thick, depending on who's making it and what you want to make it into. This sort of veneer is appearance veneer. With this sort of veneer, you actually have to heat the block, the billet as it's called, first, to make it nice and soft, and then you slice it like a meat slicer. There's a range of different slicing machines that have been used. There's at least 2 manufacturers of this sort of veneer in the state. One's just outside Burnie and one's at Smithton. Okay, so these are veneers, and these are then applied onto a substrate. So you make it into a sheet, you stick it onto something. The thing about the veneer then is it stretches the available resource quite a way, but you also get this some absolutely beautiful colours and textures that you can use on particular projects, and you can bend it. So it is quite flexible, especially if you're doing big areas. So these are what's called bundles of veneer. So when a veneer is sliced, it's sliced and each slice is kept in on the order it comes off, so that you can colour match and book match the veneers to make an even looking panel. So you don't randomise them around much. Well, you can, but that's a deliberate process. But you then keep it bundled and then you grade the bundles. Anyway, so if we're looking at grades, I use that nasty word grade. Now, because we're getting wood from trees, and trees have got their own genetics, their own living conditions, each tree's a bit different. When the producer, because I don't have to do this, that's why I went to university, is they have to grade the material. They sort it, and they sort by a series of criteria. One of the criteria is what it looks like. Traditionally, architects in Australia, designers in Australia had two basic settings. They had just wood, lovely. They had anything that looks like not just wood and it has feature, is we don't want that, you know. So they called one select, which I think is an absolutely awful name for a grade, you know, and they called another one standard, you know. Who's going to have standard when you can get select? You know, so what tends to happen then is that we've got a culture where feature is discouraged. Unfortunately, the tree doesn't know that. We haven't told the trees yet that we don't want them to grow that bit, and basically they're not interested. So we will, with material, always generate feature, and if we ignore the feature, then we do it at our loss, because we're not using the stuff properly, and there's lots of beautiful combinations we can put that feature to that we miss out because we don't actually understand what the potential is. So when we're specifying, if we've specified select for the whole thing, we're not going to get this bit of serendipity here, which is something that people are going to go past and go, this isn't plastic. You know, this is something that's grown, it's natural, and this has come from the tree. Now, the more and more you live in cities, the more and more we live in enclosed environments, the more and more important that sort of thing becomes. So if we look at determinants for visual palette, and since this is about interior design, this is the sort of thing that we're dealing with on a day-to-day basis. We can vary with colour, and colour is often a function of species, not always, but most of the time. We have grain. So grain is the configuration of the grains in the wood, in the piece. And of those pieces I'll have shown around, passed around, even though you might get two species together, two pieces of the same species, they might actually look quite different, because one grain's nice and straight, another one runs a bit crooked, and you'll get a different view on that piece. The next is feature. So this is a bit of feature here. It's gum vein. It's from an event in the life of the tree, and you can't, you know, we can use that or we can ignore it. Or we can put things together. Now, if we look at our features rather than our colour, grain and our combination, there's various types we can have. Sorry, not that we can have, that come commonly in the tree. The first is gum vein. Now, you don't get gum vein in a lot of Tasmanian stuff in most of the state, but you do in one or two particular areas, especially where it's drier. So gum vein is where the tree is damaged, it's been stressed, and it exudes this gum to fix a wound, or because there's been a fire through or something like that. And so that's inside the wood, and it's a scar. It's a healed piece. Black speck is more common, and black speck's actually a little insect which comes through the wood and leaves behind a dark trail as it moves through. And you can get it quite regularly through a piece, so it'll actually look really lovely. It'll look like a little nice line stain through the piece. And a bit of the furniture we saw earlier actually was black speck. That was the stain that was in it. So this one's called gum cluster, which is actually where you've had a cluster of little branches start, and then the tree's grown back naturally around it. Again, that's a wound effect. And then this one here is called blackheart, which of course you only get in a couple of species. In Tas oak they call it stain. In sassafras you call it blackheart, and it looks so striking that it's then highly useful for an architectural purposes where you actually want to make some really striking commentary. So this is actually sassafras, but it's all the blackheart piece. So this isn't the colour of sassafras. The colour of sassafras is actually quite pale. It's like a myrtle that's got no pink in it. So it's this colour, where this bit has come from in there. There's a piece of veneer that's gone round that is sassafras that has, that actually looks like that bit, but it isn't that bit, I can guarantee that, because... Okay, how are we going for time? Product supply and quality. Okay, there's quite a lot of quality Tasmanian oak and blackwood, and they're readily available for domestic markets, in commercial, domestic fit out, and for furniture. So it can be as a single board, it can be glued together into a larger size, it can be sawn and moulded, and it's available from a whole range of different suppliers. Some are here. Later on today, after we have a quick break, we'll get a couple of the older ones and all the oh no, I won't say it. All of them. So several of my colleagues will come to the front and we'll take questions from anyone who wants to throw them at us, and we'll pretend we know what the answers are. Okay, so, and it's available across a range of different sources. Now, most of the producers, especially the larger producers, have a long history of manufacturing quality products. So if you're a major hardwood producer in this state, you haven't stayed in business by selling rubbish to people. All of the companies have been in business for several generations, and the only way you can do that is by having happy customers that are coming back again. Now, Seesaw at the university, we, as I said earlier, my conflict of interest, the producers give us money and we earn that. I mean, I earn it by coming up and giving presentations. But my colleague here, Michael Lee, he earns it by working with all the companies to assist and improve quality basis across all of the producers. And when there's a problem, he gets the phone call. So if you ring that 1300 number, that phone's in his pocket. And if the question is too complicated for him, if it's a regulatory question or a detailing question, then I get it. So now this is Mick. Mick used to work in one of the major mills, running their drying for many years, has worked for us for the last decade, and is involved in really just in quality maintenance. He's now also doing the quality regime for the industry, which is doing examinations, inspections of all the producers and their maintenance to standards. And most of the mills now have got significant upgrades. So the old guy with the leather apron, it's a great picture of a past time. It's not what happens in a mill anymore. All the mills are run by machines, most of the heavy lifting's all done by machines, and everything's laser guided, etc. The thing though is that a lot of the supply is still family or approachable company based. So this is a group of architecture students from the University of Queensland who came down and wanted to visit some mill. So we rang a couple of the colleagues, and they arranged for mill visits. And they're all at Smithton. Okay, so like many of the mills here, there's a rack there, and you can buy from the rack, as well as have this delivered through your various supply chains. So there is a level of personability that you don't necessarily get with lots of other products you want to buy. And you can actually go all the way back to the people who've cut it, made it, etc., and supplied it. So the timber at the back is then just stuff people can come in to buy. If you go down to Glenorchy, to Mackay's, you can do exactly the same. So there's a range of different ways in which you can interact directly with the producer. There is one major technical point I want to bring up, because I mentioned earlier about how the racks got smaller over time. Okay, so wood, when wood is in the tree, it has a moisture content. The highest one I've seen is about 180%. Okay, so what that means then is that for every 1 kilogram of dry wood fibre in the thing, there's 1.8 kilograms of water in it. Okay, that was from a very wet site. So that's fine for the tree, but it's not very good for us. If I leave this piece of wood in here with this heater on, then the moisture content of this piece is going to go to about 10%. That means for every 1 kilogram of dry wood fibre, I've got about 100 grams of water. So that's what this diagram is showing. If I've got this piece that weighs 1.2 kilograms, I've got 1 kilogram of dry wood, and I've got about 0.12 kilograms of water in the piece. And that's normal. If I put this outside under cover, it might go, this time of year might go to 13. If this heater was on all the time, and we all had to take our jumpers off, then this would go down to about 9 over a period of about 6 weeks. So it doesn't happen straight away. It can be quite a slow process. All right, so why the hell is that important? Sorry, these are the parameters set out in the Australian Standard 2796 for moisture content supplied from a producer to a customer. That doesn't mean to your job, that means to the joiner, if it then goes from the joiner to your job. So it varies. Parquetry and furniture is quite tight, 8 to 13. Strip flooring and other smoulded products, 9 to 14. And decking and facades was going to be outside is up to 18. Okay, so the reason that's important is that as the moisture content of wood varies, it changes its dimension. It changes it at a known rate. It only changes it a little. But when you've got a big surface, a lot of little ones add up to a couple of big ones. And that all becomes really, really important. So wood will shrink in 3 ways. It will shrink longitudinally, that's along the piece. It will shrink radially, that's across perpendicular to the growth rings. And it'll shrink tangentially, that's around the growth rings. And if you look here, that's the shrinkage that occurs between 30% and 12%. So effectively with mountain ash, which is one of the Tas oak species, is that a piece cut at 100 across the growth rings will shrink to 87. That's a lot. Now the miller knows all this, so that's why you see those racks, is that they're drying the stuff down to a level to where they can put it into a kiln and get it down to the moisture content that we need for in the job. And so when you want to use it, you want to make sure that the moisture content you ask for is actually one that the producer can supply and that it suits the job. Now, for a little job like I'm going to put a bench in here, I'm going to put a bit of strip flooring across, this space, it's not going to be critical. But if I've got 4 basketball courts in a row, then I really want to make sure my moisture content is perfect and that the conditions under which I put the timber are going to stay that way for all of its service life. Because if I don't, and it starts to grow, because it works both ways, shrink and get bigger, if it starts to grow and it's growing at 0.3% for every 1%, 0.03% for every 1% change in moisture content, and I've got 50-metre run of board, then I'm actually adding up to a pretty big movement, which I want to make sure I've allowed for. So that's why I'm speaking about this. So if we've got a board, it's cut at 85 at 12% moisture content, so that's in the standard, that's right on the standards range. But if I put in at 9%, that board, that Tas oak board, will shrink to 84.4. Now, it's always going to do it. It has always done it. If you design it so that it can't do it, it doesn't matter because it still will. And it'll break whatever you've done. Okay, so this afternoon, if you've got colleagues coming, I'll actually show some photographs of what that demonstrates as and ways in which you can ameliorate that happening. But it's a detailing issue, and I'll discuss some of those things when we look at the projects this afternoon. Okay, certification. So if we look at timber comes from trees. We harvest the trees. So people are understandably worried. Okay, so you harvest a tree, you ruin the place, you walk away, and the place is trashed. Okay, so that's one option. The thing is, you harvest a tree, you clean the place up, you regrow the tree, and you keep on doing that, and you're planning and using science to try and make sure that that's happening as regularly as you can, so that you're not over 200 or 300 years degrading the spot any more than is absolutely necessary. So one way you can do that, you can be, as a customer, can be assured that you're getting stuff grown to a quality arrangement, is to use a certification scheme. So there's 2 types, there's forest and chain of custody. Forest is what happens for the forester. So they grow stuff with a particular quality control program in place that is based upon environmental considerations, among other things. So environment, social, a whole range of other stuff comes into it. Once the forester has harvested it and it goes through to the miller, you want to make sure that the miller's not buying 5 and selling 20 by bringing in something else through the back door. So that's called chain of custody certification. Now, both are quality control programs, effectively. So you've got to maintain a relatively rigid, paper-based quality system to show that everything's running through normally. Internationally, there's 2 major certification systems. One's called the Forest Stewardship Council, or FSC, and the other's called PEFC. They work in similar but slightly different ways. FSC is an international organisation with local branches. That's probably the best way of describing it. So FSC International is allied to FSC Australia. They're notionally the same people, and they have a certification scheme. The structure and considerations in their certification scheme is the same as in this one. PEFC works in a different model. They say, we're an international organisation and each country can develop standards that satisfy the requirements and considerations in their own country. So, a national scheme. But we will benchmark all of those against an international benchmark, and if you can show that it complies, we'll give you the tick, and you can use our logo as well as your own. So that's the difference between the two. The content of both is very, very similar. There'll be specific differences between one and the other, which I'm not going to go into because I'm not a specialist in certification, and we'd need several days to split the difference. As a designer, my key interest is that I'm always going to try and pick certified timber over non-certified timber. That's actually the big argument. That's where the most benefit comes from. In the world, probably only 15 to 20% of the wood that's traded is certified. The other 80 isn't. So the aim is to get the 80 into some certification scheme so we know that that's where the benefit's coming from. But a thing about certification schemes is that they are market responsive and they're expensive. So if people are not going to pay a premium or not going to ask for it or not going to double check, then there's no interest in the producer to adopt another process which is costing them money. If that makes sense? Foresters do it because they generally want to export a lot of their stuff. They export lots of fibre and they're big volumes to single customers, and the one customer at the end wants certification. So they'll do it. But once you get to a miller who's selling to a joiner, is the joiner going to have chain of custody certification? I can tell you, no, they're not. So the millers tend to, but the joiners do not. So there's a range of different boundary marks. If you look at Green Star, the Green Building Council's rating scheme, they accept both. If you look at most national assessments of the two, most of them will accept both as complying with everything that any government would want from their buildings. Okay, am I boring you to death yet? Okay, so I'll do this next bit a bit quickly. Carbon sequestration is another major thing. We talked about renewable materials, and here's a flip side of this. Over there on the left-hand side is a brochure. It's called an Environmental Product Declaration. If you've never heard of them, you can go onto the EPD site, and there are lots of environmental product declarations put together by major companies for everything from wood to steel to carbon. And this all comes out of the demand for people to do life cycle assessments. So there was an agreed format done. The feds encourage people, do an agreed format. Everybody does it the same way. You all publish the same figures. You all explain the same things. Everyone can do their own graphics, but you know, the best basic data is all going to be in the same format. So you can get this sort of data for all sorts of different products. This one's for kiln-dried hardwood in Australia. It's not Tasmanian, I suspect. I suspect it was a New South Wales exercise. Key thing is though, the tree's sequestering 1,200 kilograms of CO2 for each cubic metre of material. You're expending up to here, which is where you're designing, you're putting it in a building, you're expending about 400 kilograms a cubic metre in emissions. That is hauling it out, sawing it up, drying it, planing it, milling it, packaging it up before you get it into the project. So effectively, you're about 800 kilograms a cubic metre carbon better off in the building. So that's atmospheric carbon. Yeah, you've expended some fossil fuel, but most of it is actually, so this kiln drying, most of that's renewable resource. What you do after the building then can change the issue, but also these are life cycle assessment figures, and sometimes they look very low or they look very high, but at that point they're actually being assigned to another process. So it's like an end of year balance. You know, you take it out of this line and you put it into that line, so you're balancing one side off. So basic rule for me, looking at life cycle assessments over many years, is that you're sequestering, for each kilogram of wood you put in there, you're sequestering about 1.5 kilograms of carbon dioxide. You're also then avoiding using another 1.5 kilograms of high fossil fuel materials. So if you're using a bit of wood and you're not using a bit of steel, you're getting two benefits. You're taking carbon from the atmosphere and you're putting it into the wood, you're using the wood, and then you're not having to make the steel, which was going to emit a certain amount, which is usually about 1:1. Okay, so design considerations. We'll do this quickly. I spend a lot of time with my students trying to tell them the difference between material performance and a performance requirement, or material characteristics and a performance requirement. Performance requirement is what you need the thing to do in the job. You need it to have strength, you need it to have hardness, you need it to have fire resistance, and you need to have it to have durability. If we look at these four, for interior applications, our two big ones are hardness and fire resistance. Hardness is primarily going to kick it in if we put something on a floor or a wear surface, in which case then the hardness of the material becomes important. Because if you put a really soft material on and it's in an arcade and there's 2,500 people walking it over every day, they're going to total it really quickly. So that's a key factor. The next is fire resistance, and they're all things set in the BCA. So there's two sorts of fire resistance we're concerned with. One is fire resistance levels, FRLs, and FRLs we're not going to worry about, you know, because that's structural stuff and you're going to cover that with something else. You then have a whole series of fire indices which will determine where you can use particular materials depending on path of egress and a range of other similar considerations. Most wood bundles together, so none of the species that we're going to be looking at is actually going to be much higher or lower than any other species that you're going to be able to use. There is a bit of a boundary line on spread of flame, but most of that data is in those species information sheets. And certificates are available if you need them. There's then material performance characteristics, which are appearance, which is, you know, a critical thing for a designer. What does it look like? Moisture content, which is to do with functionality over time, and finishes, coatings, and stain. So we can look at that as completely. I could spend another hour on finishes, coatings, and stains, but most of the species which we're talking about can take all of those things quite well, especially Tas oak. Okay, so if we look at various applications, now I've only going to handle a subset. There'll be a few more details in a series of projects we'll have a look at. The first one is floors and other wear surfaces. Now, a lot of Tasmanian timber, especially the Tas oak range, has been widely used in floors in houses around this state and many other states now for many, many years. So here you have it in a general domestic situation in a project home. Here's another one where you've got beach in the background, timber floor, Tas oak floor, polished, fine. Now, Tas oak, blackwood then become major vehicles for flooring. Tas oak has a particular range of hardnesses or particular hardness that you're designed to. Blackwood's slightly different, blackwood's a little bit softer. Quite significant colour difference between the two. So in a domestic situation, blackwood's perfectly fine. If you're moving up to a sort of quieter commercial, then Tas oak's fine. If you're moving up into a more active commercial, then we've really got to look at something like a blue gum, because it's much harder than the Tas oak, but there's only limited volumes of it about. So from a Tasmanian species range, hardness gets to be an issue once you get into the higher end, higher volume traffic areas. But saying that, in the state library in Melbourne, there in Swanston Street, most of the major public rooms have had blackwood floors down since 1880 when the building was put up. So even quite a number of the new ones that have gone down have been blackwood as well. So depending upon volume, level of abrasions, numbers of stilettos, all that sort of thing, you want to consider which species you're using. Linings and surfaces then become a stock trade. I've just got a series of images here from various producers, various projects. This is with board as a ceiling. Here's with board. I think this is one of the extensions to the pump house project at Lake St Clair. So these are boards that have not been planed, not been dressed all round. You can still see sticker mark on the board. So you see this little shiny bit, that's where the sticker had gone through, and you've got that mark on the board. And you'll see with most of these pieces we've actually got the rough side on one and the dress side on the other. So generally, if you see a piece that's been in use for a long time, it may look rough and tumble and grainy on the outside and even grey, but it still might look like that in the middle, or look just under the surface. So you can exploit this, given you treat the boards properly and don't get too much dirt and walked on look about them. But this is actually being used quite a number of places, with things being lined or clad with material that's straight off the rack, but dried. Here's a slightly more considered use. This is for linings in a home. Now the detail for this is probably plywood behind with battens on the plywood to give you this indented surface. So you wouldn't necessarily use a full board behind, you'd ply it, colour it all the same, batten it off. And then you've got vertical battens applied with the trims around the door and a trim along the skirt. And the material is very open to sort of colour interpretation. So this is probably the same base material with a different profile and a different colour trim around the outside. Different lighting, of course, obviously. Photography makes a big difference. But these are both Tas oak. One's in a darker environment, different lighting, different surrounding colours. The next is in joinery and other sorts of installations. So you've got here cupboards and drawers, tabletops in food venues. Wood in food venues, very popular. Very, very commonly used. We'll see some of the projects we're going to deal with will be food venues or tourist venues. And then there's furniture. There's furniture of whole ranges of different types with different levels of imagination. Now, I'm not going to speculate on how some of these are made. I suspect the one on the left is veneer, but I couldn't be certain. I know quite a lot of furniture makers, and I know better than to ask them exactly how they've put it together. But there's lots of opportunities that can be exploited. So if we look at just a couple of projects now. So this is a liminal studio project. This is at Freycinet Lodge Coastal Pavilions. And these are relatively small modules that I believe you can rent and stay up there. So what we've got here is we've got Tas oak board set in a sagged pattern around the walls and probably stained to give you this colour, this even brown. We've got plywood, Tas oak plywood, floor and ceiling put in, toned the same way. This area here is then blackwood veneer. So that's the material we passed around earlier, and it's been laid on a board and put around the surface. You can tell it's veneer because you can see these regular shapes repeating in the surface, and that's because it's been sliced and you've got that cathedral, and then you've put the next one here and the next one here, and you get the change around the board. So here's a different part of the same place. Again, Tas oak in the ply and the walls, and blackwood solids and veneers in the joinery. Now with joinery, you're generally looking for a solid to go on the trims, the very surfaces, and then you're looking for a veneer to go on your trims to go around the edges, and the veneer to go on the surfaces. So that the face of the bench may be veneered, and the very top and bottom might be a solid, in which you've got an extra resilience and you're covering the edge of the veneer. Here's a completely different sort of idea and approach, much more fun. So this is a renovation of a house in Victoria, where they've, standard Victorian house, small rooms at the front, kitchen's pretty trashy. You take the kitchen off, you put a whole new big area in the back. So you start out with something much more constrained with a Tas oak floor, and then you walk into this kitchen and the light. So they've made a play of dowels. So it's just simple dowel material, board like that, sliced, put through a doweling machine, and you end up with products like this. This is called the Valley House. This is in northern Tasmania. Phil Dingemans designed it. We've got blackwood floor across here, and then we've got celery-top pine then used in the ceilings and in the decks. Now, I mentioned earlier celery is a more durable species. It's one of the few durable species we've got that will last outside. That's celery without sapwood on it. The sapwood's not very durable, but the heartwood is. It also gives you these lovely tones. So in this case, Phil's used the same material to go inside, then to run it outside. You wouldn't do that with Tas oak, because the Tas oak outside won't give you the durability that you want in a deck. It might in a cladding, especially a cladding with an awning or a cap, but not in a deck situation where you've got something sitting flat, where water's going to be sitting in it regularly. So that's one view, and there's two other views of the same project. You've got this very, very nice colour variation between the blackwood here and the paler colours of the celery-top. Now the celery-top will pale back to a slightly honey colour, but the blackwood will also go a bit darker over years, so you'll still maintain a variation between the two. This is a much more pragmatic project. So this is just a basketball stadium in Dandenong. There's a lot of Tas oak floors gone down in basketball and similar stadia. If we look at flooring, I'm just conscious of the time, if we look at flooring, there's a whole range of different options you've got for how you want to install flooring and how you want it to perform. You can put a joist down and then put a strip board across that will span 450 or 500 millimetres. And that was traditionally the base type of flooring. And then particle board came along, and then so people would make, then in a house they'd make a platform, and then you would want a timber floor on the top, and so you then put the flooring on as an overlay on top of the particle board or an overlay on top of concrete. You can, though, actually build up the whole section. So you could have a joist floor, particle board, resilient layer, something that gives you bounce, a layer of plywood, and then put the final board adhered onto the top of that. So when you're playing sport, the floor moves. And that's really important. You know, anyone who's stood up on a concrete floor all day knows that it's not very kind and generous to the body. You know, it's hard, it doesn't move much. A timber floor will move, they always do, and people want them to move. So in a sports situation, you want the movement in the floor. So there are systems whereby you design the floor to give you the resilience you want, and to make it more comfortable for the players to play the sport. The other thing you've got to be careful of with floors, especially big floors like this, is that any change in moisture content means the whole floor is going to change in size a bit. So that from a designer, that gives you 2 or 3 things you've got to do. One is you've got to make sure the moisture content doesn't change very much. That's first. Second is you've got to make sure that you order the right moisture content to get it into the project. That's number 2. And third, you've got to allow for the fact that some silly bugger is going to get it wet one day. And you need the floor to be able to move a bit and design it in to do that. And if you don't, you're going to be unhappy, or someone's going to be unhappy. We did a job, well, actually the university replaced the floor at a stadium at Newnham, and didn't ask us, they just did it. And they did come and ask us when the whole floor started to rise up in the middle of the gym, and we had them go in on three different occasions and put saw cuts through the whole floor system to give it expansion and to get them to re-ventilate underneath the floor before it settled down. So if you don't do it, you will know about it at some stage. So there's particular details of it. I won't go into any more detail today, but there is solid information on the website about floors. Now at this floor, it looks like they're all glued together, but they're not. There'll be spaces in there. You'll see the boards are relatively small. They're not very wide, and which with a basketball floor is good because you've got lots of little spaces. And you'll see that they're made up of random lengths. So looking at this from an observer's eye, this is actually an overlay floor that's been adhered to a substrate. The fact that it's glued will not stop it moving. It will still move. If it moves too much, it will pull itself off the glue if you get the moisture content situation right. But if you if you get it correct, then it'll be there 80, 90 years, and all you've got to do is recoat it every now and again. Landscape restaurant in Hobart. This is part of the IXL. A lot of hydro wood has been used in here. Circa Morris Nunn was the designers. The original Tas oak is there from unseasoned back in whatever it was put in, 1860. Sawn in big section, put in green, and then moves around as it dries. So it all looks distorted. Well, that's because that's what happens when you dry. It wasn't because they didn't have a level. It was because they put it in green, it was all straight and all even, and then it dried, and so as it dried, it shrank. So each of those columns is likely to have shrunk somewhere about 15 to 20 millimetres in length over the years. Okay, so but you get these lovely, I think, veneer top tables, and you can make these beautiful internal environments for high-grade eating. And of course, I think that's the work that won the Landscape Prize in the state some years ago. This is a bit more low-key, a bit more fun. So this is a Miss Moneypenny's restaurant in Noosa, and I looked at there are a couple of these up and down the northern parts of Australia. So this is a big open outdoor style venue. It's got a combination of species. You've got Tas oak, which is used internally. You've got blackbutt, which is used on some of these more external surfaces and linings. Blackbutt's a harder material, it's more durable, and it generally comes from this area, so the locals like it. In this project, you've got blackbutt in a whole range of places, then you've got Tas oak, which is then used in stained sections through here, through the bench tops, and up through these frames and in the furniture and surrounds. So it's all solid material prepared, stained to a particular colour, and they take stains very well, and then used in quite a flexible and robust environment. This is a slightly older project. This is a Victorian County Court in Melbourne. It's been open, I think, for about a decade now. The architectural palette here is aluminium surfaces and blackwood. And that's the two major things they play with all the way through. There is some coloured glass, but generally you get this aluminium and blackwood through. The blackwood's used in both veneers, which is slip matched with these unmatched veneers in the panels over there on the left-hand side, and then also in solids. So this is what one of the insides of the courthouse looks like, one of the courts. And so you've got large-scale blackwood veneer on faces, and you then have blackwood solids on basically all the elements that you've made, so all the joinery. Now, there was an interesting issue with this project that comes back to this basic thing about colour, but also a relationship with supply. When the architects for this designed it, they specified a colour, went along to the major producers of blackwood and said, this is what we want. And they said, well, give us 3 years and we'll have it for you. And they said, no, we can't wait 3 years. What's the problem? They said, well, you've picked part of the colour range and you're only going to take the best bit, which is only 20% of all we produce. So it's going to take us that long to do it, and we're going to have all this other stuff left. So the architects quite sensibly then work with the producer to match the colour, do colour matching in the available supply, and then use those colour matching groups in different courts. So this court will have a different tones of blackwood in it to the one on the next level. So the whole building was then mapped out in terms of the colour of the blackwood that was available. There was then a colour boundaries set, sample boards, this one and this one. If it's in between there, it's this group. And then they were used in the various courts, and the architects made sure that there wasn't two that did this. And so no one noticed. So it's not something that survived outside of the project per se, but it does illustrate when you want large quantities, highly specific setups for big buildings, there does need to be some versatility you need to show. Here's another one of the same type of large-scale project. This is the National Portrait Gallery in Canberra. This is actually a Tasmanian blue gum floor. The blue gum was picked because it's slightly paler colour. It has a little bit of grey in it as a regular feature, and also it's harder. So this was all done in shorts. So you've only got particular lengths of material, and it's all done as an overlay. So it was produced, matched, dispatched and laid as part of the floor, so that was a major installation. But then also a much more versatile a group of material was then used in major joineries and petitions. So we've got a whole series of doors, walls, wind posts, window frames then, all of which are Tas oak, all laminated together, all of which then support the aluminium frame glazing or form the doors through here that separate the major spaces. And it works really nicely. There are also glulam trusses put in the project, but I didn't want to show those, structural. Okay, so I think this is getting close to the last project. This is Healesville Country Club, and this is a relatively new project. A lot of blackwood throughout the place. It's a combination, so it's a country club. There's accommodation units there, but there's also shops and sitting areas. So here's a blackwood flooring with marble or tiled floor, blackwood through here, blackwood faced. This would all be solids. This would be a combination of veneers and solids put up there on the walls, clad columns and joinery units, and dividers. So you've got a divider there between a stairwell, where you've got simple timber boards as verticals, then with people sitting in the front. And we've got joinery here across the back, again, all blackwood in solids and veneer on a substrate. So if we look at availability and suppliers, in Tasmania, your major suppliers are for hardwoods. There's representative of Oak Industries here. There's Neville Smith's, Forest Products. There's Britton Brothers. There's Porter's, and there's Mackay's. They're your major suppliers of bulk. They will then supply to others who can also on-sell, and they can all supply you the Tas oak ranges. When you're looking at special species, there's the Blackwoods and others, the group shrinks a bit. You've got Britton's and one or two other producers who can supply Blackwood and some of the secondary species. You've got hydro wood, which then also can supply the Blackwoods and the other species coming out of the lakes. And of course, the thing about hydro wood is when they reach down and grab a tree, they don't know what it is. And when they bring it to the top, they may not know what it is either. So there's two in here called eucalypt. And that's because we don't know what they are. Well, we do. We've got a reasonable idea, you know, because around the edge is growing a couple of different types of eucalypt, but the only way with eucalypts you can tell from one species to another is by inspecting the leaves and the flowers. So if it's been underwater for 40 years, you don't have any of those left. So when you mill the wood, we believe this one is Eucalyptus nitida, which is something that is reasonably rare in the state, but it isn't where they're in those valleys which are flooded over. And this is probably obliqua, maybe, because there's obliqua growing around in the higher areas. But without doing a species examination, we can't say. These, though, are much more characteristic. When you saw them up, there's only a certain thing it can be, and so you can tell. So hydrowood has a range of special species. Britton's do. Tasmanian Special Veneers does. They make veneer products. They're represented here today. And some of the veneers that I've passed around the room have come from them. Britton's also do veneering. What else have we got? I think that's pretty well covered. Okay, so for plywoods, Taran in the state is manufacturing plywood. It's a relatively new plant. Their major market is in structural products, and they're becoming increasingly interested in architectural products. So if you want to have a chat to them, they're also here today. And they might be able to assist with particular combinations that you might have an idea for, but they don't necessarily produce at the moment. So we're also then looking at plantation material, but as I said, there's not very much of that material is currently being milled. So if you said we want to have this stuff and we want it tomorrow, I've got to say, sorry, you can't get it. Or there might be one batch and I can point you to that provider. Over the next 3 to 5 years, lots of it is going to become available, and lots of it's going to become available in a different range than this thing where we take this and we put it on the wall, or we make a bit of table out of it. There are people now who are looking at manufacturing in Burnie CLT, cross-laminated timber of different types, out of the plantation Knighton's material. We don't know what it's going to look like yet. They don't, I can guarantee, they don't. We don't, but that's something that will develop over the next 3 to 5 years. So I say that not to really complement this stuff, is that if you're interested in wood, it's actually going to be more and more and more available in a range of different products, and you can investigate it further across the next couple of years, and there'll be a lot of additional options for you to look at. At the moment, there's a lot of really nice stuff that's out there that has good traditions of use. Thank you very much.